Alright, this lesson is all about factoring by grouping. Pretty much if you notice that there are four terms, the first thing you're going to start thinking about is factoring by grouping. Okay, for the grouping method, what you do is you take the first two terms and treat it like it's its own polynomial, and then you group the last two terms. Now, looking at these first two terms, what is the greatest common factor, the GCF? Well, hopefully you notice that 8 divides into both of these. So the GCF is going to include 8, and variable-wise, r squared. Both terms have at least 2 r's. So there's my GCF. Now, what's going to be left behind? Well, this is going to leave behind r minus 8. Okay, and you know what? I'm going to show you where this came from one time. I'm not going to do this every time because I'm going to figure that you got it. But look at this GCF. What we are really doing is we are dividing by the GCF. I'm dividing by 8r squared. So if I do that on the first term, the 8's cancel, and r to the third power divided by r squared, that just leaves r, because the bottom two r's cancel out two of these r's and just leaves the 1. And 64 divided by 8 is 8, and the r squareds totally cancel out. So that's what's really happening. Now, on this one, it's already r minus 8. It's even positive. So all you really have to do is go ahead and put this in parentheses. Okay, and just put r minus 8. Now, for this method, you're going to want to go ahead and put the 1 in front of the parentheses. It'll make the next step more obvious. Now, notice the parentheses that are alike. All right, that means this red is a common factor. R minus 8 is itself a common factor. And you know what we do with common factors. We always put the greatest common factor out front. So that means we're going to put r minus 8 out front. Now, imagine for a minute that I were to erase the r minus 8s. Look what would be left behind. 8r squared plus 1. Okay, so we are taking these r minus 8s away and putting them in front. But you can see that what's left behind is the blue. 8r squared plus 1. You should always look at this and see if it's something that can be factored further. And it cannot. So this is the final answer. Alright, looking at problem number 2. If we group these two terms and these two terms, the common factor, let's see, both of these are divisible by 3. Hold on. So we will have 3, and then p squared, the lesser number of p's, will be the greatest common factor of the first set. That's going to leave behind 4p minus 7. So we're hoping this turns out to also be 4p minus 7, but I guess we'll see. Over here, both of these are divisible by 7. 7 goes into 49. So we'll bring out the 7. That means on the inside, guess what? 4p minus 7. The parentheses, once again, are the greatest common factor. So we pull that out in front. So we will have 4p minus 7 out front. And that's going to leave behind the blue stuff. So that's 3p squared plus 7. This cannot be factored. It's addition, not subtraction. These aren't perfect squares, so this is the final answer for number 2. Any questions? Just kidding. Okay, what's the common factor on these terms? Well, 2 is the common factor and x squared, so 2x squared. That's going to leave behind, let's see, 6x plus 1. So hopefully this will be 6x plus 1 somehow. Now here, the common factor, both of these are divisible by 5, but you see the negative sign, so that means I'm going to think of it as negative 5. And 5 times 6 is 30, so we'll have 6x. And negative 5 times 1 is negative 5. So check it out, 6x plus 1 2 times. That is the common factor, so once again I'm going to bring that common factor out front. So I will have 6x plus 1 in the front. If I take that away, that leaves the blue stuff behind. So I will have 2x squared minus 5. This cannot factor any further. That means this is the final answer. Alright, number 4. We'll group these two and these two. Let's see, these are both divisible by 2, best we can do there. And of course the v squared is happening. And let's see, what does that leave behind? 3v minus 8. So hopefully this one will be 3v minus 8. I guess we'll see. Does 3 go into both of these? Well, I know 3 goes in, no. It's 2, okay. I'm looking at 21. And I know that 21 is 3 times 7. Okay, so do either of these go into 56? That's the question. Well, 7 goes into 56 as well, because this is 8 times 7. So 7 is the common factor here. All right, so I'll put a plus, and I'll bring out the 7. Now that's going to leave behind 3v minus 8. Oh, look at that. What a coincidence. We have a common factor, so we need to bring that out front. So that'll make 3v minus 8. If I take the red away, it's going to leave the blue. So that's why I will have 2v squared plus 7. You should always ask yourself, wait a minute, can we factor this anymore? Especially if you see that it's quadratic. All right, it's squared. But no, this is unfactorable. So that's the final answer. All right, guys, be very careful on problems like number 5. I got caught off guard, and I'm very sleepy, so I'm going to blame that as well. But I did not notice the common factor. So I did this whole problem, and I got an answer, and I thought it was the right answer. And I didn't notice until later that I really had not completely factored it. So be careful. It turns out all 3 of these are divisible by 3. Now some of those should be obvious, like 63, because 6 is divisible by 3 and 3 is divisible by 3. So you know that 3 goes into 63. And like 90, you know, because you got the 9. Now, I might have mentioned this on another problem, but here it is again. If you want to know if any number is divisible by 3, add up the digits. Okay, so for example, if I want to know if 54 is divisible by 3, alright, I'm going to go, 54. 54 is 5 plus 4. I mean, you know, it's not 5 plus 4, but if I add up the digits, I get 5 plus 4, and that's 9. Since 9 is divisible by 3, that means 54 will be divisible by 3. Okay, you could do the same thing with 105. Okay, if I add up the digits of 105, you know, it's 1 plus 0 plus 5. Well, that's 6. Since 6 is divisible by 3, that means 105 is going to be divisible by 3. So add up those digits. So all 4 of these numbers are divisible by 3. They all add up. The digits in every case add up to something divisible by 3. So got to use those tricks. Use the tricks. Now, so we need to pull out that common factor before we start the problem. At the end, after doing this problem properly, I'm going to show you the wrong answer that I had at first. And because you'll probably make the same mistake at some point, I'm going to show you how to recognize your mistake and fix it without having to redo the whole problem like I'm doing. So anyway, we're pulling out a GCF of 3 from the entire problem. So that's going to look like this. Okay. 63 divided by 3. That's going to be 21. So I will have 21 n to the third power. Alright, 54 divided by 3. Okay, that's 18. So I've got plus 18 n squared minus. Alright, 105 divided by 3. That's 35. So I've got 35n. And 90 divided by 3, of course, is 30, because 9 divided by 3 is 3, so put the 0 back on there. So this blue is what we must factor. Now, just in the end, we'll multiply, we'll put the 3 in front of everything. But for right now, just focus on the blue part. So we'll go ahead and do the blue part like we usually do. Okay, so let's group these two, and we'll group these two like normal. So let's see, what's common here? Both of these are divisible by 3. So let's go ahead and pull out 3n squared. You know, like you do. And that's going to leave behind 7n plus 6. Okay. Now, over here, these are both divisible by 5. So since it's minus, I'll consider it to be a negative 5. And then that's going to leave behind, interesting, 7n plus 6. Negative 5 times positive 6 would be negative 30, so it makes sense. Luckily, they're both the same, so I can pull them out as a GCF of their own. So 7n plus 6, if I pull them away, that leaves behind the blue part, which is 3n squared minus 5. Okay? Now this is the correct factorization of the blue part. But don't forget about the 3 that we pulled out in the first place. It hasn't gone anywhere. So that 3 is sitting out front waiting for us. And now that we have this all factored out, we can just go ahead and put that 3 in the front like that. Okay, so that's why this is our final answer. Okay, watch out for a common factor, especially when you see a lot of big numbers. Look really carefully and see if there's a common factor. Now, let me show you what I did the first time around and show you how to fix it without redoing the entire problem. Okay, so the first time around, I didn't see the common factor, so I factored it like this, and see, I put a box around it. I was like, yay, this is the answer, yay, I'm done. But here's why I should have known that this was not the right answer. I've told you guys this before. You should never have a common factor in your parentheses at the end of a problem. If you do, you're not finished. So I'm pointing at this blue one because what's the common factor that's in here? Yeah, both of these are divisible by 3. Okay, so what you need to do is pull out that 3. So I don't have to, when I see this and I realize, uh-oh, I shouldn't have a common factor, I don't have to start all the way over. I can just pick up from here. So just focus your eyes on the blue part for now. The common factor is 3, so I can still just pull out that 3. But you know what, I'm going to make it green so you can keep track of it. Alright, I'm pulling out the common 3 here. Alright, that's going to leave behind 3n squared minus 5. Agreed? Now, right now, I still have the red part. Alright, I've still got the 7n plus 6. So really, I have 3 factors. I have 7n plus 6, I have the 3, and then I have the 3n squared minus 5. I have all 3 of these things multiplied together. Alright, but it's more traditional to put this single constant factor out front. Okay, I mean, I would accept this as the answer. I mean, there's nothing wrong with it. But if you think of it, it's more traditional to put that out here. And let's see if I can just slide these closer. Okay, so this is more traditional, what we would expect to see. So this would be our final answer. Okay, without having, we could just fix it without having to redo the whole problem. Is that what we got before? 3, 7n plus 6, 3n squared minus 5. Okay. Okay, same thing. Alright. Alright, if you just watched the video from number 5, I mentioned that I made a mistake on number 5, and I did not realize that there was a common factor, so I did the whole problem without pulling out the GCF. I made the same mistake on number 6 as well. Didn't realize it till later, and I had to come back and fix it. So, cautionary tale. Please be careful. Watch yourself. All 4 of these are divisible by the same number. Can you tell what it is? Well, looking at the 21, there's only 2 possibilities. Because 21 is 3 times 7. That's it. Well, and 21 itself. Okay, 84 is divisible by 21. I'll come back to that. 15 is divisible by 3 and 5. So both of these are divisible by 3. But obviously it's not divisible by 21. It's not divisible by 7 either. So, but look, both of them are divisible by 3. Is 60 divisible by 3? Yeah, 60 divided by 3 is 20. So all 3 of these are obviously divisible by 3. 21, 15, and 60. What about 84? 84 is not quite as obvious unless you know the trick that maybe they taught you in school, or if you watched the video from problem number 5, I taught you the trick then. A shortcut for knowing whether or not a number is divisible by 3 is add up the digits. Alright, like 84, the digits are 8 and 4. So if I do 8 plus 4, 8 plus 4 is 12. Okay, guess what? Since 12 is divisible by 3, you get 4, then that means the original number 84 is also divisible by 3. Okay, so that works for everything. So even the ones we know for sure, like 15, we know that's divisible by 3. But check it out, 15 is, the digits are 1 and 5. That makes 6. It's divisible by 3. We know that this is 3 times 7, but let's check out our new shortcut. The digits are 2 and 1. Add them up, you get 3. That's obviously divisible by 3. Even this one is 6 plus 0. Well, that's 6, so it's divisible by 3. So again, if you add up the digits and you get something divisible by 3, that means the number itself is divisible by 3. So, since all of these are divisible by 3, 3 is the common factor. And we need to bring that out before we do the rest of the problem. Okay, so let's do that now. So if I divide all these things by 3, this is going to be 7k to the third power. Let's see, 84 divided by 3. Let me just check that out. 84 divided by 3 is 28. Alright, so this will be minus 28k squared. And this will be plus 5k. And this will be minus 20. Alright, I just divided all 4 of these numbers by 3. And there you go. Okay, now let's concentrate on the blue part and do the things that we usually do. Okay, so for example, if we group these two and we group these two, the common factor here is 7k squared. So I'm going to bring out that 7k squared. Alright, that leaves behind k minus 4. Okay, now on the other grouping, they're both divisible by 5. So I'm going to bring out positive 5. And that's going to leave behind k minus 4. Okay, before I do anything else, once again, that 3 that we pulled out, it's still there, hanging out. Okay, it's still there. Don't forget about it. But anyway, back to the inside stuff. Just like we always do, we're going to pull out this common factor and put it out front. So I've got this k minus 4 that it's a GCF that gets pulled out front. Now the blue part is the part that's going to be left behind. So I'm going to have 7k squared plus 5 left behind. Okay, now that 3 that's been hanging out the whole time is still there. Now that it's nice and factored, it's all multiplication, I don't need this square bracket anymore. I can just bring down the 3 and put it in front. So this is actually the final answer. Okay, now just like I did on number 5, let me show you what I did the first time, so I can show you, because this is probably going to happen to you at some point, and you won't realize until you finish the whole problem that you didn't pull out a GCF. Let me show you how to fix it without redoing the entire problem. Okay, so looking at number 6, this is what I had at first. This is what I thought was my answer. Put a box around it and everything. But I should have known, guys, that this is not the final answer. Because right here, I told you guys that if something is completely factored, there's no way it's going to have a common factor inside the parentheses. What are these both divisible by? Yeah, they're both divisible by 3. So what you need to do is factor out that common factor of 3. Okay, so I am going to pull out the GCF. So focus on this blue. Alright, I'm pulling out a 3. Okay, now if I do that, so dividing everything by 3, that's going to leave 7k squared plus 5. Look familiar? Now I've still got this k minus 4 thing happening, so I could bring that down. Alright, I'm just trying to keep everything in the same order for a second so you can easily follow where everything came from. But really, it's more traditional to put the constant factor in the front, so let's just swap these around. Okay, I'm going to put the 3 out front here. And let's just move these closer together. Okay, so this would be the traditional way to write this answer. And now this would be the final answer. Okay, 3k minus 4, 7k squared plus 5. 3k minus 4, 7k squared plus 5. Okay? So the moral of the story is, if you don't notice, alright, I mean, think about it. I guarantee like 10 of you would not have noticed that 3 divided into everything. And if I look at all your homework, I'm betting that there'll be 10 of you that did the same thing I did, and you got this right here, the k minus 4, 21k squared plus 15, and you thought that was your answer. But if you notice, even at the end, that there's a common factor in the parentheses, you can still pull it out and then write your answer. Okay, for number 7, we'll pair these two and these two. The GCF here is 5v squared. 5v squared. And that's going to leave behind 5v plus 1. Over on this one, the GCF is 6. Alright, and that's going to leave behind 5v plus 1. Oh, look, another coincidence. Let's bring this out. 5v plus 1. That leaves behind the blue stuff, which is 5v squared plus 6. Okay. This video is long enough, so I'm going to end it here, and I will pick up the next video with number 8. Alright, so to be continued. I'll see you on part 2 of the video.